Okay guys, so on 5A and 5B, we first need to remember and recall all of our parent graphs, right? We should know what a linear parent graph looks like. It's a line crossing through the origin. We should know what a quadratic parent graph looks like, which is a parabola with the vertex 0, 0. We should be able to remember what a cube function looks like, which is that S-shaped curve that crosses through the origin. So obviously this right here is that S-shaped curve that crosses through the origin, but it's no longer at the origin. Bottom line is we need to be able to look at this and identify that the parent graph really is y equals x to the third, right? Know that the parent graph of this weird looking graph is y equals x to the third, then we could talk about how it transforms to become this new graph. So the original goes right through the origin like this. It has the center point at the origin, and this new one does not have the center point at the origin. Where is that center point at, guys? Right there. What is that coordinate?
1, 2.
That is the coordinate 1, 2, right? So that's the coordinate 1, 2. Let me zoom in. That's going to be 1, 2. So, how do we get from the original parent graph, which is something like this, which crosses through the origin, how do we get from there to 1, 2? That's really a translation of two types. How does it translate? 1 to the right and 2 up. So the h value of 1 and the k value of 2. So your new equation will be y equals, the h value is inside parentheses with x, and we said the h value of 1 because it goes 1 to the right, which means inside the parentheses it looks like a -1. It's still to the third power, and the k value happens to be going up 2 because it got shifted 2 units up. So the important thing is to recognize that the parent graph starts at the origin, or it has a center at the origin. This new center is 1 over 2 up. So 1 over is -1 in there, has a h value of 1, but it looks like a -1. And 2 up is the k value of +2. The simple answer that you need to write on your test, this is a Friday's test, would be down here where it says EQ. That's the equation. So please write down your equation right there. Y equals x minus 1 to the third power plus 2. And the t represents the transformation. So what would we say on the transformation part? You would say, and there's a transformation that the cubic parent graph shifts 1 to the right and 2 up. So on number 6, what form is it in? Oh yeah, by the way, I messed up. You need to write a 2 up here. It's a parabola. I messed up. There should have been a 2 up there. So this is a parabola in vertex form. What's the first thing to identify? The vertex. 1, -4 is your vertex. So let's go and graph the vertex at 1 and -4. It'd be that dot right there. Make it a big fat one. Hopefully nicer than mine. And then we're going to do a axis of symmetry, going right through that value. And now at this point, all we need is more coordinates. All we need is more coordinates. So we could go to an XY table, or we could use the original pattern of A equals 1, which is 1, 1, 2, 4, 3, 9, and modify it to make it the new pattern of A equals 3, which would simply be multiplying these guys by 3, and you'd get your new pattern of 1, and 1 times 3 is 3, 2, and then 4 times 3 is 12, and 3 and 9 times 3 is 27. Now that's your new pattern for the A value of 3. It's ridiculous to have the pattern 327. You're not even going to use that. But let me show you how you use this pattern. 1, 3 from the vertex. You know it's opening up because it's positive. So you're going to go 1, 1, 2, 3. And then the next one, 2, 12. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's already off the graph, right? So you don't even need the 2, 12 part, just the 1, 3. So if you go 1 and 1, 2, 3, you end up right here at this coordinate. Map it over to the other side. There it is. And ladies and gentlemen, you've graphed your parabola with the critical points right here and there. to 9 and 10. Let's focus in on 10. These guys are pretty tricky. They're kind of like number 1. What do I actually give you? I give you the vertex, which is an h value, a k value, and I also give you a point, and the point is a x value and a y value. And you want to write an equation, and we should all know that the equation's y equals a parentheses x minus h squared plus k, and all we need is an a, an h, and a k, but we don't have an a. We have an h and a k, and we also have an x and y, so we could plug in our h and k and our x and y into h, k, x, and y to solve for a, which is our missing value. Kind of like number 1 from this practice test. So if I do that, I'll have 5 equals a, we don't know, we're going to solve for a. X happens to be negative 3 minus h, which is minus 1, squared plus k, which happens to be a plus 1 also. And if we solve, we're going to end up with a negative 4 inside of the parentheses, a plus 1 out here, an a value right here, an equals, and a 5. And if I do the negative 4 squared, I want to get 16, and 16 times a is 16a plus 1, and we have the equals 5 over here. Subtract 1 on both sides, you'll get 4. Whoa, my bad. Let me erase. So we get 4 on this side equals 16a on this side. So we need to solve for a, divide. Final step is to divide by 16, divide by 16. And what does a actually equal? 1 over 4, 1/4. There we go. So the a value is 1/4. A value is 1/4. Okay, so the original question was to write the equation, all right? And we know that the equation is in vertex form. It's the easiest way to write it. All you need is the a, the h, and the k. And we actually do now have an h and a k, and we also have an a. So let's write our answer. Y equals 1/4 parentheses x minus h, which is a minus 1. Don't forget the square. And then plus k, which is a plus 1 at the very end. Ladies and gentlemen, that's our answer right there for number 10.